Alright, so let's prepare ourselves. This one is a difficult one. Doing adding and subtracting is really difficult. Multiplying and dividing, not difficult. We're going to do the difficult one first, just like let's get that one out of the way. Alright, so we're going to use this that we just looked at. We're going to say if ever we have to move the decimal to the right, we're subtracting from the exponent. If we ever have to move the decimal to the left, we're going to add to the exponent. Okay, right here the practice problems gives us exactly what we need to do in order to add or subtract. So let's add. Now, this concept is exactly like this one. If I had 2.4, we'll say a to the 20th power. You guys see where I got this? 2.4, and instead of saying times 10, I'm saying times a to the 20th power. This says times 10 to the 20th. I'm saying 10 times a to the 20th, okay? And if I have to add this to 4.5 times a to the 21st power, I can't do it. These are not like terms. Their exponents are not the same. Does that make sense?
Yeah.
Okay? You're not used to seeing really big expos like that. You're used to seeing, like, if I had 2.4 a to the second power, I cannot add that to 4.5 a to the third power. You know, that's what you're used to seeing. Those are not like terms, so you cannot add those. But because we're in scientific notation, we can actually manipulate these tens a little bit. Okay? So check this out. Now we can either change this 20 into a 21, or we can change this 21 into a 20. I think it's always easier to go down, like make this 21 into a 20. I think that's easier. So I'm going to ignore the way they did it and show you my way. You see this 4.5? We're going to work with him first. So I want that exponent to be a 20. Watch this. 4.5 times 10 times 10 to the 20. Is that true?
Yeah,
because I just took 110 out of this, right? This 21 means you're going to multiply 21 tens to it. Well, I took 110 out, and I have this. Okay, what is 4.5 times 10? 45.0, right?
Yeah.
10 to the 20. Ooh, so now I got the same power as this one. Everybody's cool? Everybody's with me?
Yeah.
Now look what happened. I moved the decimal over to the right one, and then what did I do to the exponent? I subtracted one. If I move the decimal to the right, you subtract from the exponent, right? Now, if you choose not to memorize this, and because you understand this, that's okay. Okay, I'm just giving you guys two different tools to do this. I like this better, but some of you guys like these, I guess. So let's do the problem now. We have 2.4 times 10 to the 20. And we're adding that to 45 times 10 to the 20. Now the complicated way, I think it's complicated, it's kind of confusing, is they factor out the 10 to the 20. Don't write this. I'm going to undo this in a second. If they factor out 10 to the 20, then you're left with 2.4 plus 45. And then you add those together. If you guys had $2.40 and you added it to $45, how many dollars would that be? You'd have $47.40. And then you're multiplying that by 10 to the 20. Correct? So your scientific notation would look like this. 47.4 times 10 to the 20. And then you're almost done with the answer. But that looks all confusing to me. Let me show you it this way. That's kind of like what this is telling you to do. Let me show you a different way. Instead of thinking about factoring it out, let's just go, okay, we got common like terms right here. Like we had like terms, we would just add the two numbers that are in the front together, right? So let's just do that. Let's go 2.4 plus 45. You guys said earlier 47.4. Then you have times 10 to the 20. You look at 10 times 10 to the 20 like it's a variable, kind of like it was a, okay? And you just add the numbers in front. This is like the coefficient, which I told you guys earlier, okay? So this is not entirely correct scientific notation, but it is correct. we want that decimal to be right here before the 7. So what would my exponent be? If I move this decimal back 1,
21.
what is my exponent supposed to be? If I move it back 1, we're supposed to add to the expo. So we get 21. That is more correct scientific notation. Now for the next one. I just gave you a chance to do it. All right, let's do this. Now like before, I like changing the bigger one, the bigger exponent to the smaller one. So I'm going to change the 15 into the 13. Okay? So I'm going to change, let's do the changing in blue. We're going to go 1.42, and we're going to go times 10 times 10. Now, what's another way to write times, or 10 times 10? You can say times 10 squared if you want to, but I'm going to leave it like this just to try to help you with understanding. The last one, what will this exponent be on this one now? 13. Because we have to have 15 tens, right? So we got one right there, we got one right there, and now this is the 13 left. Okay, does that make sense? Now instead of writing it like that, I guess I could have written it like this. I could have just said times 10 to the second power times 10 to the 13th. And 2 plus 13 is 15, right?
Yeah.
And now I'm actually going to multiply the 2 tens to the 1.42. So this goes away. Okay? So if I multiply it by 2 tens, if I multiply 1.42 by 2 tens, what's going to happen to that decimal? It's going to move twice to the right. So I have 142 times 10 to the 13. Now my exponent on the 10 is the same as the other one.
So now you can subtract.
Now I can subtract numbers in front. So what is 142 minus 2?
140.
Yeah. Remember, this is like a variable, and this is like a variable. It's like an A. Okay? So you just have to subtract the coefficients, which in this case is 142 and 2. You get 140 times 10 to the 13. Okay, now is this proper scientific notation? No, because the decimal's right here. We want the decimal to be after the 1. So what would the exponent be? Exponent would be 15.
You moved it twice.
Yeah, I moved it twice. Where? To the left or right?
To the left.
To the left. So then we add to the expo. Now, do I need that 0? Nah. But it does kind of help us understand if I have it there. But I'm going to take it out because I don't need it. That's your answer.
That makes sense.
Those ones, the adding and the subtracting ones, those are the hard ones. Because you can't add unlike terms. And with tens, we can manipulate it so that they have like terms. So like now it has 10 to the 20, 10 to the 20. We were able to add. Multiplication? Not the case. We love multiplication. You know why? Because if I had, let's see, 7a to the negative 9, I'm just writing it like something you know. So 7, and instead of writing times 10 to the negative 9, I'm going to write times a to the negative 9. And I multiply that by 5a to the 5th. You guys can totally do this. You can multiply these two. Actually, let's get rid of that point and let's go like that. What would you do? You go 7 times 5, right? And what would you do those exponents? You just add them together. That's exactly what we're going to do. They wrote it right here for us, but let's skip this step. Let's not do that. Let's just go 7 times 5. So we don't have to write it out. And we go times 10 to the negative 4. Because that's what negative 9 plus 5 is. So after that, the decimal is after the 35. And I remember that always by going, oh, $35. If I handed a cashier $35, it would say 35.00, right? So that means we know that the decimal is at the end of the number. Now I want that decimal to be after the 3. So how does that change my exponent? If I move the decimal to the left, inside of scientific notation, if I move the decimal to the left,
You add. So
you add.
Negative 3.
Negative 3. You add 1 to a negative, it's going to go, oh, it looks like it goes down.
That's it?
That's it? You like it?
Yeah.
Here, try this one. Try this one down here. Alright, so what we're going to do is we're going to go 1.42 and 2.4, and we're going to multiply. Let's see, let's go 1.42, 2.4. I know this is algebra 2 trig, but let's do this. 4 times 2 is 8, and then we got 16. We add 1, we get 5. We We have a placeholder right there. We have a 4, an 8, and then a 2. We add all these dudes together. We get 8, 10, and then 14, 3. Move the decimal over 1, 2, 3 times. So we get a decimal right there. So we have 3.4. Did I add wrong?
No, you're right.
Oh, I just didn't carry I didn't show you I carried the 1. All right. 8 times 10 raised to the 28th power. Oh, snappity wackety. Is this proper scientific notation?
Yeah.
Yes, because the decimal is right after the first non-zero number. We don't even have to change anything. That's beautiful.
So that's all.
That's it. Division is just like multiplication. So like if I had 1.2 a to the 15th, and then I divided it by 3a to the 7th, that's what we're doing right here. Okay, so I'm not going to, well, I mean, this is correct, but I'm not going to pay attention to this. I'm just going to go that divided by that. So 1.2 divided by 3. I put the decimal there. 1 divided by 3 can't do that, so I put my 0. 12 divided by 3 is 4. So you ignore the decimal when you're doing all this stuff. And I subtract, I get 0, so I have 0.4. So I get 0.4 times 10. And what do I do with these exponents?
Subtract.
15 minus 7 is 8. Now, is this proper scientific notation?
Yeah.
No.
No.
The decimal has to be after the first non-zero number. So it's going to be 4.0
Oh.
times 10. Now,
7.
what's going to happen to my exponent?
Subtract.
Yeah, I moved this to the right, correct?
Yeah.
I moved to the right, so you subtract from the expo.
7.
Last one, here we go. This divided by this, 1.42 divided by 2. Put your decimal there. What's 14 divided by 2? So I have 14, I do my subtraction action, and then I put 2 right there, so that's 1. So this equals 0.71 times 10 raised to the negative 5 minus 13. You subtract these exponents. So what do you get? Negative 18. Oh, but wait a second. We have to move this decimal over 1. So it's 7.1 times 10 to the what? If I move it to the right 1, what do you do? Subtract. So we get negative 19.